You can visit our website for the commands in the videos. If you want to purchase other study materials like packet tracer files and other course guidelines, then you can email to us. Follow us on Facebook for further updates. Please do like, share, comment and subscribe so I can quickly deliver more videos on various topics. So in this video, we are going to have a look at access list. So I have subdivided my concepts. So one by one, we'll have a look. So first, why access lists are needed. Then IP traffic subdivision, and then access list types and which type you need to choose as per your requirement. And then numbered access list ranges, and then named ACL introduction and services, protocols and port numbers, and how to write access list, and access list command explanation. How can you easily recall and write the access list implementations? And then implement access list simply. By remembering a small short command, you can implement further access list one by one. By developing from this particular commands, you can implement it. And then after your access list implementation, you need to apply it to a particular incoming interface or outgoing interface. Okay, and we'll have a look at what incoming and outgoing traffic, and then how to apply it by using the access group command and what are access class command. So here in this diagram, let's see why we need access list. For example, let's say if you are having this kind of network, two routers and switches, and one LAN is coming under 192.168.10.10 network, and other LAN is going for the 192.168.20. network. Okay, in between I have attached 1.1.1.1 and 2. Okay, so by using this method, once after you configure the OSPF or RIP any routing protocol, you can ping from 192.168.10. network to 192.168.20. network, right? But as an administrator or technician, you might desire to have more control over your IP packets or services by controlling or by permitting or denying particular services of packets. For example, you might desire to allow only TCP protocol packets to be transferred, not the UDP ones, or else you might desire to allow only ping packets except the web traffic, or else you might wish to allow only the web packets except the ping packets. Okay, and maybe from one particular IP address you wanted them to have access on a server. From other IPs, if you wish to block, you can block it by using the access list. It's kind of a filtering technique. Okay. Access lists are used to have more control in your IP packet. Okay, it's a layer 3 security protocol. So in early days, firewalls have been doing the same thing by filtering packets. Okay. We'll have a look at firewall in a later lesson. So now let's move on to ACL. So next we'll see what are IP traffic subdivision. For example, if you consider IP, you can subdivide it into TCP, UDP and ICMP, okay, which is our ICAM packet. When we try to ping, we will use the ICAM packet, right? And under TCP, you can have Telnet, FTP, File Transfer Protocol, SMTP, and web traffic, www. Everything comes under TCP, Transmission Control Protocol, and UDP, which has DNS, DHCP, and TFTP, etc. Okay. So based upon each and every protocol, you can use the access list to have more control on your IP packets. So by doing this, you can specifically permit only telnet packets, or permit only SMTP packets, or block DNS, or block FTP. Likewise, you can have more control in the IP packets, okay, by using the access list. Once after you write the access list, you need to apply it to particular interface, okay. Next, we'll have a look at ACL types and choice of use. In access list, we can subdivide it into numbered access list or named access list. Numbered, you can subdivide again into standard or extended. So in this, if you have standard access list, you will have a specific number allocated for the standard ACL. Extended means another specific range of numbers, okay. For example, standard means in the access list, you will specify 1 to 99, or else 1300 to 1999, okay. Or else, if you are using extended, you need to use the number range from 100 to 199, or else to 2000 to 2699. In named ACL, we don't use number ranges to specify whether it's standard or extended. We directly specify standard or extended when we configure the ACL, okay, by the name. So next, we'll have in-depth lookout on standard and extended ACL performance, okay. So when you create a standard access list, so in standard ACL, you can apply the access list entirely to IP traffic, okay. You can't specifically configure for TCP traffic only, or UDP specific, or protocol wise, or service wise, or destination based. Likewise, you can't do it. In standard ACL, what you can do is you can configure access list entirely for the IP traffic and as well as the source network or IP address, okay. In standard ACL, you can't control about the destination. So due to this issue, whenever you write a standard ACL, you will apply the standard ACL close to the destination. Since we can't specify anything regarding the destination on standard ACL, we are writing the access list on destination side and applying it as close as possible to the destination, so that more specifically we can control the destination part, okay. In extended access list, you can have more control over your IP traffic, which means you can talk about the source network or IP address, or its destination network or IP address, or else the protocol based control or the service based control like telnet, FTP, SMTP. All these you can perform via the extended ACL, okay. And here's a small demo to how the packets work on standard ACL, okay. So now let's say, for example, you want to control the IP traffic from 10.network, 192.168.10.network to 192.168.20.network, okay. So you wanted to block the traffic coming from 192.168.10.network to 192.168.20.network, okay. So this 10.network is going to be the source, and this 20.network is going to be the destination. So what we are going to do in standard ACL is we are going to write the access list in the destination side and going to apply it as close as possible to the destination, okay. So let's take for example, in this router, you are going to write access list like a list of conditions. For example, condition number 1, 2, 3, like that. List of conditions are there. You are specifying from 10.network. If somebody enters, just block the traffic, okay. And likewise, one by one conditions are there, for example. And then what happens is you will just paste the access list in a particular interface. It's kind of like you are having some conditions written on a paper and you are placing a security guard in that particular area. So whatever the traffic passes from here to reach that particular interface, the security will check the list of conditions, and as per the conditions, whether the traffic will be allowed, either it's allowed or denied. Okay, so permit or deny. Okay, access list is a layer 3 security. So this is what happens in the standard, and similarly, more similarly, extended also performs the same, and you will have more control over the traffic, more specific control over the traffic. In standard access list, you can't specifically control the destination. For example, you can't control traffic, you can't deny traffic for 192.168.20.20, and you can't permit traffic for 192.168.20.10. Because in standard ACL, if you apply a standard ACL here, it will be controlled over 192.168.20.network entirely. You won't specifically control a 20.20 or 20.10. In extended ACL, you can have that facility as well. Okay. In order to apply the access list to the interfaces, we are using access group command. Okay. And also specifically, if you wanted to apply access list based upon a specific service, you can use access class commands. When you start writing the access list, it's better to know the protocols and services and the port numbers. Mainly it's used in the extended ACL. For example, FTP traffic uses port number 20 and 21. SSH uses 22 and Telnet 23, SMTP 25, and DNS, which is using UDP, and DHCP as well, using UDP, and both are 53. Likewise, it goes. DNS uses UDP and it uses the port number of 53, and DHCP going to have 67 and 8, and web traffic mainly it's going to be under 80. Web traffic www, which uses port number 80, or SSL, which uses 443. So web traffic and SSL are TCP traffic. You can have a look at that in the screen. So you can refer the protocols and absence services and port numbers in the display. Okay. If you feel hard to remember each and everything here, you can simply use the second chart. Okay. Remembering this one would be a great help for writing the extended ACL, which we will write in the few moments. Access list statements are checked one by one. For example, let's say if you have 4 commands on an access list, so first statement will be checked when the traffic comes. Okay, so if that traffic rule matches, then the traffic will be permitted to move, whether if the traffic is about permit. Okay, let's say the first statement is about permitting traffic on this particular 10.network, which means if that particular statement matches, the next second or third or fourth statements or lines are not going to be checked on that particular traffic, because if the first one matches, it will be allowed or denied as per the rule. Okay, if that particular one is not unmatched, the first statement is unmatched, means the second one will be tested. If this matches, the action on the particular rule will be taken. Even if this didn't match, then one by one it will proceed. Okay. At last, in each and every access list, once after you configure it, in the end there will be a implicit deny, which means deny all. Okay. So this is kind of like this. You can specify each and every specific prioritized traffics one by one. Okay, rule by rule, it's being processed. For example, 10.network, 20.network, 30.network. So likewise, you are specifying for this router. If this router has 20.network and 30.network, 40. Likewise, if it has other networks involved, you can specify the rules as well. Okay, so one by one, when you are specifying, there might be some other networks which you didn't specify, which you missed to specify. For example, 80.network also there in this router. So if you didn't specify anything regarding that route, the access list automatically match that particular traffic with the deny all statement, which is coming in the last of that. You won't see it, it won't be visible, but it's already prefixed in the access list protocol. Okay, so implicit deny. So if your initial statements are unmatched, the packet will be checked against the deny all statements. So which means each and every packet from out of this network statement, access list statements, are going to be blocked by this deny all statement. So if there's a 80.network and you don't have any access list for 80.network, which means at last it will be checked against the deny all statement. So 80. is going to deny that particular packet. Okay. For example, you have written a statement for 192.168.10.network should be permitted in the first line. So whenever the traffic comes to this router 2, it will check upon the first statement. Okay, 10.network has been permitted, so it will be permitted to the destination. And you have written something for 30.network to block, to deny 30.network. Then it will be checked against the 30.network deny, so it's going to be blocked. But if you haven't specified any rule for the 80.network, it will pass out from 1 to 4, right? So all 4 statements will be unmatched, and in the end the deny all statement will match with the 80. And it will consider it as a exception one, so it's going to block this 80.network as per the 5th law, which is deny all statement. Okay, so let's say, for example, you have certain rules for access list. You have specified for 10.network, 20. and 30. But again you missed to specify for the 80. But in the end, you don't want this 80.network to be denied by automatically. So what you want is, whatever the networks you missed to specify should also be permitted. So to overcome that deny all, we need to write permit any command in the end of access list. Okay, so you will see that when we write access list one by one, I will explain how to implement each and every command in an easier way. Okay, this is just an introduction what we are going to do in the upcoming session. Okay, so since the access lists are checked in a sequence, first the statement 1, then the statement 2, then 3, 4, likewise it's going in a sequence. So we need to write the main prioritized traffic statement in the top, in the initial state. Okay, so then only it will be checked in the first place. Okay, so that's the reason. You can visit our website for the commands in the videos. If you want to purchase other study materials like packet tracer files and other course guidelines, then you can email to us.